Hey guys, so now we're going to start getting into some of the measurement stuff, and hopefully we'll be able to get you in the lab right away. At least that's my hope, because that's one of the things that if you're in an AP science class, about 20% of the instruction is actually supposed to be on lab. And that's one of the best feedback things that I've gotten from my students is they went on to college, they went into the chemistry lab, other students are really floundering, and they were just whipping through, knew how to take proper measurements, knew how to handle their data, and they could get a titration. And they're getting good results. So part of this is knowing how to work with what we call significant figures, or we abbreviate that and we say Sig Figs. So what exactly are Sig Figs? I don't like the way they teach this in a lot of the resources, so they kind of treat it separate or independent of the measurements. And really what the significant figures is all about is this stuff, all right? So we got to be able to measure things. And when we talk about significant figures, it's how many of those numbers or digits that we gave you are significant, in other words, are giving us exact measured information. The digits are pretty easy. So I've got some numbers up here. So for example, right here, if you see 102 grams, how many sig figs does it have? Well, that's obviously 3, okay? So if I put something on a scale, and this would be a pretty inaccurate scale, but if that's what I had to work with, what we'll say is digits are always significant. So the 1, the 2, down here we see a 7 or 4. Those are obviously significant. You wouldn't put down those numbers unless it's actually measuring something. Zeros are the things that give us a problem and give students a hard time. This one right here, whoops, that moved around a little bit, is, let's move that back. Okay, so this 0 right here is significant because what I would say is it's a sandwiched 0. And what does that mean? It's sandwiched in between numbers or values that are obviously significant, and that means they're measured. It gets a little tougher when these zeros are at the beginning or end of a number, and that's where students start to struggle a little bit. Okay, so if we take a look at this one right here, so that's something maybe you'd measure in a graduated cylinder like this one. I don't know how well you can see that, but this one goes to the milliliter. This is also going to bring up another point. So I'll have a student that goes up, you measure from the bottom of the meniscus on liquids, that means the bottom of that little curve thing, and it lines up with a 47. And so the student will write down 47 milliliters, and then they get marked down for that. And they're like, what? But it was on the 47. And it's like, well, if it's exactly on the 47, you'd say 47.0. Because of these little notches right here that you can see, you have to estimate where it is in between those notches. So you can estimate to the 10th of a milliliter. And when you're using non-digital devices in the chem lab or in the physics lab or in engineering or any kind of measuring, there is an assumption that the last measurement is an estimation in between the smallest divisions of the scale on that device. So if it was at the 47, and right on that you'd say 47.0, because if it was a little over, you'd say 47.2 or 47.3, or you'd say, hey, I think it's kind of right in the middle between the 47 and the 48, so then I'll say 47.5. That is a measurement, so therefore it's called significant. Okay, so it's giving us some information about how much volume there really was in this. How about this guy right here, 0.630 grams? What do you think? A lot of people will say, hey, 2 sig figs. There's a 0 tacked on at the end of the number. That's just a placeholder. Well, no, it's not actually a placeholder. That was just like the 47.0. Final zeros to the right of the decimal means the measuring device goes out that far, and so it wasn't 0.632 or 0.635, it was right on the mark. It was 0.630 grams. Our scales will measure out to the thousandth of a gram. I'll be kind of fussy with you guys. Those kind of scales are very expensive. All right, the cheapest ones you can get are $500, and they go $1,000 to $10,000. So, playing around with it and seeing if you're blowing on it and stuff, how much can I make the numbers jump around, will get me a little excited. All right. Now, what about when we start doing stuff in scientific notation? And that one, so that has 3 significant figures. That's the only acceptable answer. Doggone this thing. All right. I have to be a little careful with a new toy because if I bump it in the wrong spot, it pops up a keyboard and then it shifts the stuff. 3.00 times 10 to the negative 2 seconds. So we'll have some stuff that happens really, really fast, and we have measuring devices that are electronic that can measure some really fast speeds. Well, what exactly is the number of sig figs? When you're putting stuff in scientific notation, it's really easy. Anything right here that's in front of the multiplier, okay, this times 10 to the whatever, tells you where the decimal really is. 3.00, all those numbers are significant, okay? There's 2 ways you could look at it. The 3 is significant. That 0 is the final 0 to the right of the decimal, so it makes that one significant, and now those zeros are, kind of squeezed in there. It's a sandwich 0. Or what we can take a look at is, what would this be if it's in regular notation? Okay, if I change this over, 1, 2, this would be point, decimal point, it's kind of a terrible decimal, 0, 3, 0, 0 seconds. Okay? You can't change the number of sig figs when we put it in scientific notation or otherwise. So that 3 is significant, and those 2 zeros are significant. So this has 3 significance. That 0 right there is what we call a placeholder 0. It tells you how big or how small the number is. That serves the same function as the times 10 to the whatever. Okay, tells you where the decimal is. So how big or how small the number is. Okay, so that one's a little bit longer. I wanted to give you some of the stuff that are common mistakes that I see people make. I'm also going to show you something where we get in a really bizarre situation where the only way we can show the proper number of sig figs if it's in scientific notation. So that's it for now.